In this video, I'll be discussing two case studies of similar fuel pump failures. The first vehicle we will investigate is a 1998 Ford F-150 with a 4.2-liter V6. The symptom was an intermittent cranking no start that became a consistent cranking no start. My group began diagnosing this vehicle by first injecting some propane into the intake to bypass the fuel system. Luckily, this first test caused the truck to start up, at least initially, indicating a fuel system issue. We then had to determine if the issue was due to the injection system or a fuel delivery issue. To do this, we used a stethoscope on the injectors and heard pintle movement, indicating the issue being a delivery problem. This was confirmed by performing a fuel pressure test at the shown test port, which was kind of hard to find, but we were able to find it like you see there in the image. And we found 0 psi of fuel pressure, which is obviously not good. At this point, we began to suspect the fuel pump, so we wanted to check the fuel pump circuit integrity. This was done by putting a low amp current probe around the fuel pump power wire after the inertia switch, as you can see there in the diagram. We were then able to see the fuel pump current ramp on the scope. Unfortunately, this waveform was not saved, but what we saw was 14 amps of current flowing through the circuit. This amperage is too high, which proves that the wiring is in good shape, but the pump was likely shorted. Faulty wiring would not be able to handle this amount of current. Next, the fuel pump and sending unit was removed and replaced with a new unit, and this fixed the vehicle. A current and voltage waveform was captured from the energized old pump on the bench. As you can see from the top waveform, the pump was only dropping 7.8 volts. On the bottom waveform, the current ramp was a flat line at about 13 amps, indicating the pump was internally shorted. We should see a wavy pattern. Only a quiet gurgling sound was heard from the pump. Okay, so here's our old pump sending unit from the truck that we've been talking about that does not start. And this is actually where the pump itself would have sat, although it's been removed so we can do our bench testing. And this is the level sensor there. It's just a rheostat that basically tells your gauge how much fuel's in the vehicle. So that's what the sending unit looks like. And here's the old bad pump housing. We can see here's our outlet of the pump, and here is our electrical connector where the wiring would hook up for the fuel pump power and ground. And this has been cut open by me. It's not designed to be taken apart, as we can see there, but there's the housing. Here's the actual pump itself, the pumping unit, and there's two pump halves, and they're a little scraped up, but that's just from me taking it apart. There was actually no issue with the pumping unit itself. So fuel would enter right here in through that orifice, and it would travel around this channel here, and it would be pulled by this impeller, or propelled by the impeller that splines to our pump armature that's driven by the electric motor. And this just has vanes on it that pulls the fuel around to the other pump half, and it'll go around this channel and output, and eventually come out of this top hole here. So that's the pumping unit. Here are the permanent magnets that are internal to the pump, because this is a DC brushed permanent magnet motor. So those would sit inside the housing. And here we can start to see our issue. Here is the armature from the bad pump. And as we can see on the commutator area, where these 8 segments are, we can see that the plastic has melted from too much current going through it, from being shorted and heating up and melting and being basically destroyed. So that was our root cause of our problem in our pump failure, is from it overheating essentially. We can actually see a portion of one of the carbon brushes melted to the commutator segment right there, which is not good. So that's our problem right there. Here's the fuel sock. This is it's kind of a pre-filter, by the way, for the fuel system. It kind of sucks the fuel through here and filters it before it enters the pump, so that's what that is. And I'll just show you a quick example of what a good unit should look like. So here's a brand new pump. There's the housing again cut open, and here's the armature and the commutator, and you can see that's what it's supposed to look like. And here's the melted one. Something else we noticed is that these commutator bars are completely flat on the new unit. There's no lip or anything, it's just a flat surface. However, on the old one, from those brushes riding around for so many miles, it actually created an indent from the into the commutator bars from the brushes in the electric motor, which is kind of cool to see. And the brushes actually live down there in the pump, and they're all melted and broken off in this pump, the bad one. And the new ones, you can see them, they're much longer and not damaged, and they ride on springs to keep constant pressure on the commutator itself. Up next, we had another similar F-150 from a customer, also with a cranking no start complaint. First, a fuel pump current ramp was taken with a fuse buddy in place of the pump fuse and current clamp. A toggle switch type relay replaced the factory pump relay, as you can see in the image, and this was used to activate the pump to get an amperage waveform of the fuel pump. This time we saw another flat line of pump current near 19 amps, again indicating a shorted pump. We would expect to see current to be closer to 5 to 10 amps for a pump like this. Okay, now we're going to take another look at these armatures again. So here is the brand new pump armature. So this is what it should look like when it's brand new. You can actually see the balancing marks there on this pump armature to prevent vibration, and they all have that actually, so that keeps it in balance because these guys rotate super fast. Here is the first armature I showed you off the first vehicle we spoke about in that first F-150, and you can see again how melted this one is with the brush actually melted to the commutator there. And here is the armature off the customer F-150. As you can see, it's also the same issue. It's super melted and it overheated. You can see discoloration in the metal from how hot it got on the commutator. Maybe not quite as bad as this one here, but again, same root cause on these two F-150s that caused them not to start, were these shorted and melted armatures within the fuel pump. Kind of cool. Hopefully this video helped you understand fuel pump diagnostics and some root causes of pump failures. Thanks for watching.